Like right here, if I were to draw a tangent line, it would be like this. Right? At C. What's the slope of that tangent line? Negative. So it's decreasing. Questions? 3. The max and min values of a business cycle are called the peaks and troughs. Label them on the graph. So, surely we can do that. You guys, can you pick the peaks? There's a peak. There's a peak. Can you pick the troughs? Here's a trough. Here's a trough. Peaks and valleys, peaks and troughs. Highs and lows. What can you say about the rate of change of the GDP at these peaks and troughs? So again, when it asks me for the rate of change, I'm thinking about the slope of a tangent line. So if I have to draw a tangent line at any of those points, what would the tangent line look like? I think I agree. I wouldn't use that horizontal. Yep. So at any of those points, if I were to draw a tangent line, the tangent line would be horizontal. Is everybody okay with that or not really? So because the tangent line is horizontal, that means the slope is 0, so the rate of change is 0. If you think about what was happening all along the way, the slopes of these tangent lines would be positive, 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 positive. Then it becomes 0. Then what happens to the slopes of the tangent lines? Negative, 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 0. Right? So those are the points, those peaks and troughs are the points where the rate of change switches from decreasing to increasing. Okay, 4, is the GDP increasing and decreasing at a constant rate? So when it's decreasing, is it always decreasing at the same rate? Or when it's increasing, is it always increasing at the same rate? No. Why not?
Because it's curved. Yeah.
It's not linear. To have a constant rate, it would have to be lines between the peaks and the troughs. Those are not lines. Right, they are curved. 5, at point D, GDP is increasing. Do we agree with that? Okay. Is the growth of the GDP speeding up or slowing down? How do you know?
The line gets less steep.
So the slope of that tangent line is starting to flatten out, right? As you reach a peak, the slopes of the tangent line starts to flatten. So it is increasing, but it's increasing at a slower rate than it was at F, right? At F we were increasing, but it was increasing more quickly. Can you tell the difference when I say that? Both F and D are increasing, but D is increasing more slowly. Yeah? Okay. When is the GDP changing the fastest? And how could you tell from the graph? So if GDP is changing the fastest, what am I looking for? Graphically.
The steepest line.
The steepest tangent line, right? The tangent line with the steepest slope. So where would the tangent line have the steepest slope?
F.
It doesn't have to be a label point. It doesn't have to be a label point.
In the middle. In the middle of the curve. In the middle of the peak and the trough.
Which in this case is represented by this dashed line, right? At the dashed line, the tangent line will be the steepest on all of these. As I went past that dotted line, it would be a little less steep, a little less steep, a little less steep. Right? Can you see that on the dotted line? Everywhere on that dotted line where it meets the graph, the curve, that's where the GDP is changing the fastest. 7a, at point E, is the slope of the curve negative or positive? What does this mean in the context of the problem? So because the slope is negative, you're right. The slope is negative at E. What does that tell me? What does the slope of a tangent line tell me?
How much is decreasing by?
It tells me that GDP is going to decrease after point E, right? We're still going to be decreasing. Slope of tangent lines tell me which direction the graph's going. Because it's negative, we're decreasing. At point E, are the slopes increasing or decreasing? So we said it's negative, right? So here's where you've got to get the difference between positive and negative means one thing. Increasing or decreasing means something else, right? You have to know the difference. So at E, because the line has a negative slope, it is negative slope. That means that the GDP is decreasing. Okay, but what's happening to the rate of change? Are the rates of change increasing or decreasing? They're increasing. As I get closer here, I'm getting less negative, less negative, less negative. I'm increasing the slope, even though it's negative, right? Because it's starting to head back to 0. You guys follow that? Think your way through that? So then what does that tell me? If the rates of change are increasing...
Wait, is the slope increasing or decreasing?
The slope is negative, but the slopes are increasing.
So if it was positive, it'd be decreasing?
Not always.
No. Where the...
We'll look at each point here in a second. We'll see if we can tell.
From D, it would be...
We're looking at E, right?
Yeah.
So because the slopes are increasing, that means that the rate at which the GDP is dropping is slowing down. Right? So the GDP is still dropping, but it's not dropping as quickly as it was here. This is where it was dropping the most quick at this point. And now that it's starting to drop less quickly, the slopes are becoming closer to 0, so it's increasing. The slopes are increasing. Say it correctly, the rates of change are increasing, even though the actual Y value is still going down. Right? So if I look at each one of them, like if I look at A, is the rate of change positive or negative? Positive. So that means Y's are going to be increasing. But is the rate of change increasing or decreasing? Think about here, what was the rate of change? You would be the most steep, right? So now that it's getting a little less steep, a little less steep, a little less steep. So the rate of change is decreasing, okay? Until it reaches here at 0. The rate of change is 0. And so then what's happening at B? At B, are the Y's increasing or decreasing? Decreasing. We're going down. What about the rates of change? Are the rates of change increasing or decreasing? They're also increasing, right? We're going to be getting more negative until we hit that point. And then it's going to start to flatten back out. So then at C, the GDP is negative, right? The tangent line will be negative there. But it's doing it in an increasing way, right? So we're getting closer to 0. And then at F, the GDP is positive, going up, and it's doing so in an increasing way. We're getting more steep there, up to this point. Okay? Can anybody think of another way we've talked about this recently that we might could label it? Like, think about so we said the dotted line is where the slope of the tangent line is changing the most quickly. What else is happening at the dotted line each time? In the context of something else we've talked about, Thursday or Friday?
It's in the middle.
The average,
Not necessarily A-Rock. Don't think A-Rock. That's what's something we focused on. What else have we talked about? Or maybe I talked about it, you guys just sat there. Maybe that's the way it went. You guys don't like a good math lecture? You're not fans of the math lectures?
I have no clue.
There you go, thank you. Thank you for that. What's happening on the dotted line with concavity? Switching. Right here, what's the graph? It's concave down. When does it switch from being concave down to concave up?
When it hits the dotted line.
When it gets back to the dotted line. It goes from being concave down to concave up because the rates of change are increasing. So it's concave up here, and when does it switch being concave up? At the dotted line. At the dotted line, it switches back to concave down. Okay? So those points where we switch from concave up to concave down are called points of inflection. That's a vocabulary word. So on that next little spot, if you want to label it on the graph, you can. Or on the next page where you have your notes.
The line is the line of inflection.
The line, every time the graph touches the line, the graph switches from concave down to concave up, or concave up to concave down. And that point where it switches is called a point of inflection. That's where the slope of the tangent line is at its most extreme, right? Either it's most negative or it's most positive. It's always happening at that point of inflection.
It's called the what?
Point of inflection. Inflection. Okay, look at the check your understanding. See if we can do those kind of quickly. X equals -1. Increasing. How do you know that?
I thought it was decreasing.
So what's decreasing? This is where you have to differentiate what you're talking about. What is this asking me? What is F doing? What's another way to think about F? Instead of saying f of x, you used to just call it y. So if it's asking, is f increasing or decreasing, what's happening to the y values when x is -1? They're going to keep going up, right? Again, if you think about that, and again, my brain goes right to tangent line. If I look at the tangent line here, the tangent line has a positive slope. So because it has a positive slope, the f or the y values are increasing.
What type of graphs are these?
Polynomials. So like you've probably dealt with like a quadratic is a polynomial. It's a degree 2 polynomial. A cubic is a polynomial. Okay? But then we could keep growing the degree. I can tell you by looking that it's going to be an odd degree polynomial. Could be 3rd degree or 5th degree or 7th degree. That's all I can tell you. And we'll talk more about that later. How I know that. 2, is the rate of change of f increasing or decreasing? Decreasing. How do you know? It is getting flatter. The slope of the tangent lines are decreasing. All that's true. Like there's nothing wrong with that. And last year, that's the way I would have explained it and left it at that. But I know how they're going to test it on the AP test now. And so they want you to answer it in terms of concavity. So if I had to answer that again, everything you say is correct. I don't want you to think you're wrong. Because as you grow to calculus, that's exactly how we would explain it and be fine. But in pre-cal, they want us to focus more on concavity. So the rate of change is decreasing. And how do I know? Because the graph is concave down. And when it's concave down, the rates of change are always decreasing. Okay, so I'm trying to change my instruction to put more of an emphasis on concavity because I know that's what they're going to ask you on the test. They want to answer in terms of concavity. On what interval is this graph concave down?
Maybe from less than 27.
So do we see an end point here? No. So we're going to assume this graph continues like this forever. And it's going to keep going left. So we start at negative infinity on the left. So what's the graph doing to start with? Is it concave up or concave down at the very beginning? Concave down. So where are we concave down? Well, starting at negative infinity, we were concave down. And then as I go from left to right, when does this stop becoming concave down?
It doesn't.
Well, I mean,
Does it look like everywhere would repel water? Is there somewhere that the water would hold?
I mean, it's like 0.7.
Like
like
point 6. Good job, Ken.
I think somewhere right in there. Is that where y'all see it?
That's
That's where I see it, where it changes. Okay? When I visualize it, like sometimes I can see it other ways, but if I think about my tangent lines, I would be drawing all these tangent lines over here. Now that I do it again, I think I'm going to shift it over a little bit more. It's going to be more here. Okay? Because as I go slopes of tangent line, I'm here, here. The point of inflection is the point where I would switch my tangent lines to be on the other side. I mean, that's the way I visualize it in my head. Not that you guys should be able to do that yet, because it's still kind of a new idea. Let's just say that's at a half. I'm good with that. Does it go to be concave down again anywhere?
no.
Not that we see. So where's this concave up?
1, 2, 3.
Not one.
Point.
0.7.
0.5. 2,
That's my point of inflection. What's a point of inflection? Where it switches from increasing to decreasing or decreasing to increasing. If I'm telling you this point is no longer concave down, then it has to be concave up. Or it had to be a horizontal line, which it's not. Okay, so. And so we've really done this. What would be your x value of the point of inflection? Yeah, whatever you picked here. I mean, that's kind of repetitive. They just want to make sure that they use that terminology, point of inflection. I think is all that question's about.
It's because they just want to seem like sophisticated people, but
Yeah. Yeah. Okay, I like this one. They tell us the rates of change. It's like a matching situation. So I have 5 different rates of change. Negative 4.25, negative 3, 1, 4, and 9.75. And I have to fill those in at their proper x value. Okay, so when I look at these, I'm going to have 3 that are positive, 2 that are negative. Okay, so let's just figure out which ones are positive and which ones are negative. So at an x value of negative 1.5, should I have a positive or negative rate of change?
Positive.
At negative 1.5, should I have a positive or negative rate of change?
Positive.
How do you know?
It's going up.
If I look at the tangent line, it has a positive slope. So I know this one has to be positive. Right? I'm just kind of going through process of elimination here. What about at negative 1?
Positive.
It's going to be positive. It is decreasing, which tells me what? It's going to be less positive than here. So it's not going to be 9.75. Okay? Do we follow that? So I'm just going to make myself that note. I know this is not 9.75. What about at 0? What should I have?
Negative.
At 0, we get a negative one. At a half. So we said a half was about the point that it switched, right? So it should be negative. And if this is my point of inflection, that is where it's at its most negative. Right? At the point of inflection, the slope is at its most extreme every time. Either most negative or most positive. So because it's negative, I know this one's negative 4.25. And I know this one's negative 3. Do I follow that? My logic? And then what about at 2?
Positive?
Yeah, and it is positive.
But it just is freshly positive.
It's just freshly positive. That's a good way to explain it. So which one of these would be? Yeah, that's the least positive one we have. Because it's the closest to horizontal. So that means this one has to be 9.75 and this one have to be 4. If you can reason your way through that, you understand the different slopes of the tangent lines at all these points. Okay, that's the kind of exercise we would do. Questions? That's a good one. Okay, let's keep going.